When you modulate a control in phaseplant, like in most environments, the response curve looks like this. This graph shows what value a target control will be set to when a modulator outputs a given value. So when the modulator is set to a 0, the target is set to a 0. When the modulator is set to a 50, the target is set to a 50. When the modulator is set to a 100, the target is set to a 100. It's a linear relationship. When you double the input, the output is doubled. But sometimes you want this response curve. When the modulator is set to 0 or 100, the target is set to 0 or 100. But when the modulator is set to 50, the target is at perhaps only 10. This can be useful in many situations, for example when you have a macro that moves a wavetable position, and also which increases the mix of an effect, like a reverb or a distortion, but you only want that effect to have a strong impact when the modulator is very high. You may also sometimes want a curve like this, something highly nonlinear. In this situation, you can program specific output values mapped to specific inputs. So when you input a 10, a 40 is output. When you input a 40, a 90 is output. And an input of 60, a 0 is output, and so on. You can create any curve that phaseplant's LFO editor will allow you to. The way to achieve this in phaseplant is by making an LFO have an effective rate of 0 by modulating its phase position at the same rate as its oscillation rate. You can then scrub to different output values by modulating to the phase on the first LFO. Here's how to implement it. I don't think it matters what the rate is so long as they're the same. I'm setting mine to sync 416. Take off read trigger on both, set the phase on the first to positive 180, and change the curve shape to ramp up. Now modulate the phase on the second with the output of the first. Use a value of negative 50 and make sure to right-click the modulation wheel and actually type in the value. Getting this wrong can cause strange behavior, since phaseplant rounds the actual values of controls to whole numbers for display purposes. Modulate the phase on the first LFO with a macro. Set it to negative 100%. Now my macro movements will be remapped according to the shape on the second LFO. Watch. When I'm at a value of 0, the LFO is outputting 0. When I'm at 25%, the LFO outputs 1, which is the value 25% of the way through this LFO. When I'm at 50%, it's at 0 again, and at 75%, it's at negative 1. You can draw any shape you like in this second LFO, but be aware that some controls in phaseplant are unipolar. They go from 0 to positive 1, and some are bipolar. They go from negative 1 to positive 1. One thing to be careful of is that when values reach 0 or 100%, they can start to cause bouncing in the output, but you can get past this by slightly backing off 100% values further up this modulation chain, and then rescaling it depending on what you're controlling with this curve. Let's do something practical. I'm going to make a simple growl. I'm going to create a wavetable, load it with a factory growl wavetable, and then use macro 1 to control the wavetable position. I'm also going to add a saturator, and rename macro 1 articulate. I'm going to set up an LFO to control articulate so that I don't have to do it manually. This is the shape I'm going to choose. I also want to use Serum's bend warp mode on this wavetable. I have a tutorial on how this works linked in the description. The bend is controlled from using the warp macro, which I'm going to modulate using my main articulate modulator. I prefer if the bend had a strong effect only once articulate was near the top, so I'm going to create remap LFOs. Route the articulate as the input, unroute articulate from warp, and route the output of my remap LFO to warp. I can now draw a hockey stick style curve so that my bend only has a strong effect at the top of articulate's range. Let's try something more exotic. Here I have a simple analog sawtooth patch playing a simple riff. In this snap heap, I have two parallel buses. On the right parallel bus, I have a gain unit and a delay unit. The percent of the gain unit is modulated by macro 1 at positive 50%. This setup means that the delay unit always has its output turned up fully, but only receives new input when macro 1 is turned up. The effect is that I can feed certain parts of the riff into the delay and then stop the input without losing the feedback decay. I want this to only happen on the note G. I could achieve this by automating the input of my delay to only fire at certain points in my riff, but that doesn't help with live performance, and it means if I rewrite my riff, I have to change the automation. Instead, I'm going to create a note modulator and use it as the input to my remap LFOs. My riff spans C4 to C5, so I'm going to set the center of my note modulator to B3 and the range to 14 semitones. I can now create a remap curve that is flat, other than in the chromatic 7th position, because G is 7 semitones above C. I can now route the output to the input control of my delay unit, and whenever a G is triggered, that note and that note alone will echo.